this next one, question 5 on homework 21. They're asking us for the integral from 0 to 2 of 10x e to the x squared dx. You're going to see the x and you're going to freak out, and don't freak out because it's really not that big of a deal. This isn't that challenging. We're going to be able to use the exact same procedures that we did use on the first few to do this, and it's going to be a piece of cake. So we know we're going to be using substitution, so let's rewrite this as e to the u du. This is an integral we can find. This up here is not an integral we can find. So that means that our u equals x squared. I said e to the u, this is e to the x squared. So we have u equals x squared. So the derivative of u with respect to x is going to be 2x. That means du equals 2x dx. And this is one of the cases where we've got something extra here that doesn't match up, but we've also got something extra up here. I've got 10x here, I've got 2x here. And like I've said before, if you don't want to have to think about it in any other way, if you've got it arranged on the paper like this, the extra from up here goes into the top of the fraction, the extra from down here goes into the bottom of the fraction. Okay? So that gives us 10 halves, which when we simplify in a minute is going to be 5. But just remember that if you have something extra here that doesn't match up, it goes in the bottom of the fraction. If you have something extra in the original function, that goes in the top of that fraction. Organize it on your paper like this, and it's really easy to see where these things are coming from. Okay? So let's go ahead and simplify that. That's the same as 5 times the integral of e to the u du, but we cannot forget to plug in our new bounds. We need u bounds because we had x bounds. So my upper and my lower, these are going to be pretty simple calculations. I'm going to take the 2 that was my x bound and plug it into my u. So 2 squared is 4. Now I'm going to take my 0 that was my lower x bound, plug it into u, and that's going to give me 0 squared, which is 0. So my new bounds are going from 0 to 4. Okay? And now we solve, and this one actually is kind of simple because we've got this e to the u, and we know the integral of e to the u is just e to the u. So we've got 5 e to the u from 0 to 4. Plug in our values. That gives us 5 e to the 4th minus 5 e to the 0 power. Well, e to the 0 power is just like any other number to the 0 power. It equals 1. So that's going to be 5 e to the 4th minus 5, which is a perfectly adequate answer. You can put that into WebAssign without any issues. But you could also rewrite it as 5 times e to the 4th minus 1, which is their official answer that they're looking for. But this one would be okay as well. All right, so don't freak out because you see the e to the u, because it actually means that you've got a bit of an easier integral to deal with. Let me make sure all of that's on the screen. It is, so that you can look at it and copy it. The tricky part of this one is that we had something extra in our du and we had something extra in our original function. We just had to remember, if it's extra in the original function, it goes into the top of that fraction. If it's extra in the du, it goes into the bottom of that fraction. Piece of cake.